Hello and welcome to my channel. Just to start off here, I got a new mic, so hopefully everything sounds a little bit nicer. Today we're going to be looking at my design for our harmonic gearbox, which ended up being more of a hybrid planetary gearbox. But anyways, the original reason for designing this harmonic gearbox is, well, I found it really interesting once I learned how they worked. And I needed a good gearbox for a robot platform I'm working on. Initially, I had planned to use 4 of the 540 powered worm gearboxes that I designed. They ended up being a pain to build and not as reliable as I originally hoped for, so it sat on the shelf for a while. Recently I noticed a lot of other 3D printing guys on YouTube were making harmonic gearboxes and different planetary gearboxes and cycloidal gearboxes, so I kind of started paying attention and looking around, and I kind of fell in love with how the harmonic gearbox works and the fact that it has zero backlash. So I got to work designing my own gearboxes. I ended up playing around quite a bit to get a decent design, and I figured I could make the flexible gear from TPU, which turned out to require way more power lost in just flexing the gear than I was really willing to put into it. So I changed gears a little bit, so to speak, and went with 2 floating planetary gears mounted on the similar rotor as I would have used for a cam with the flexible gears. After playing around with that idea for a while, I come up with a working prototype. Success! The original design powered by a NEMA 17 stepper motor controlled by my large CNC controller. I didn't really intend to use stepper motors to drive my robot around. They just don't really seem to be the greatest things to be having naked outside. So I started playing around with 540 motors. Originally I had purchased 3 cheap eBay 540 motors that I was going to use on the robot as drives. So I hooked one of those up to the harmonic gearbox. Instantly it didn't seem like it had enough torque to turn it over, and eventually I let the magic blue smoke out. So that was a bust. So I switched out to a known good 550 motor, and it still didn't want to spin, but at least I didn't let the magic blue smoke out of this motor. So I had to play with some of the tolerances and loosen it up a bit, and even then it didn't really want to spin too well, so I threw some grease in it, and that seemed to make a big difference. After covering everything on my bench in a fine layer of grease, I let it run for a little while to try and work it in, and it ended up welding the little planetary gears to the shafts that I had them just bushed onto. So back into Fusion, I modified the gears with a little bit more clearance on the inside hole, and I gave them a little hole to the outside in between the teeth. The idea behind this is hopefully it would pump grease into the pin and keep everything lubricated nicely. This seems to be a great improvement, as well as making the motor easier to spin. You can see that the grease flows nicely around the inside of the 2 ring gears and is kept in there rather nicely, so it should hold up rather well in practice. The only issue I come across is with the 550 motors, it's still a little too much input load and they seem to get really hot. So for my purposes of possibly a robotic snowblower or robotic lawnmower, probably not the best motors to be using for that application. To solve that problem, I ordered 2 brand new 775 brush motors and redesigned the base plate of the motor to mount to the 775 motors. These just showed up in the mail, so I've yet to get them all in and wired up and see how it works, but I think I'm going to leave that for part 2. But some notes before I let this end. There is a few variants I made up for the outputs of the harmonic gearbox. One of them is a shaft that is designed to fit a wheel that I previously designed for the worm gearboxes, and the other one is a larger diameter printed part that would have thin wall bearings holding it up and would be more suitable for a robotic arm or some sort of actuator in short movements. But that's about all I got for now, so I'll be back with part 2 later. I hope you guys liked what I'm working on and hope to see you again.